Good evening, everyone, and welcome to today's session. I think so. Can we give another minute for people to join?
Yeah, sure.
So I think we can start slowly. So almost all of them have joined now.
Yeah. So, firstly, welcome you all to today's webinar. And today we'll be doing sort of a practical session of what we have learned, the theory we have learned yesterday, how different call parameters can be used, and what are some of the most common parameters you can use in amphibian research. Of course, for other groups of vertebrates, it may be slightly different, like birds will have syllables and etc. But however, for frogs, these parameters hold good across various different types of studies in this taxa. Okay, so welcome you all again. So let's move on. If you have if you're using your system, kindly keep Raven Pro Lite, which you have downloaded ready. I think Raven Pro complete software is not easy to download because you need license from Cornell Lab, for which you need to write a mail to Cornell Lab uh, mail and then get the license. Then it will take about 24 hours for the license to get activated. You'll get a code. Then you have to add that code along with your email to activate your one of Raven Pro software. Okay, so I don't know how many of you have Raven Pro software already. If you don't have, it's not a problem. At least if you have Raven Lite software, it is for free. You could have downloaded. If you're not downloaded, quickly download and keep it ready. Because initially, I will teach you how to do the analysis. Later, if you have the software, you can try it out. And now I'll wait for some time and for your reply or answer because I have already shared some calls with you based on which I will ask you to analyze one of the calls and send me some of the parameters of the calls. Okay, so that you also get some hands-on experience because it is more like a workshop what we are doing where we also try to learn because acoustics is a technical field where unless you do it hands-on, it's very difficult to understand because it's technical, right? So let's start with it. So I'm going to use the Raven software now and show you how some of the parameters and what is Raven first. I'll teach you from the very basics. I will not do any higher level of teaching here, but basic analysis of sounds. Okay, very fundamental call characteristics as I explained you about 9 to 10 call parameters yesterday. We are going to analyze those 9 to 10 call parameters today. Okay, so shall we go ahead? Hope all of you are ready. First, you listen. If you have the software, kindly keep it ready. I'll ask one of you or all of you to use those calls which have given one of the calls among that. Then you do the analysis as I tell you here. So I'm going to open the Raven Pro software now. Can you see the Raven window?
Yes, sir.
Okay, so this is called Raven Pro. Like I have the most latest version because I have got license about 10 years back maybe. So I have Raven Pro 1.6.5. So if you're getting license maybe this week or next week, you will also get the same software. This is a software developed by a team of researchers from Cornell Lab of University. Okay, Cornell Lab of Ornithology. Okay, from America or US. And these people are experts who are expert physicists, biologists, okay, and taxonomists who have developed this, mainly physicists. It's a lot of physics is involved in that, mathematics and algorithms are also involved. But however, even I am not a technical expert to tell you. I am working as a biologist. I sit as a tool for a biologist. As most of you here also, I believe, are biologists who want to use this for some sort of analysis of your sound of your tax of interest. Maybe it is a bird or a frog, or maybe it is a mammal. I don't know what you really want to work on, what you're interested, and what's your you know take from this webinar. Okay. However, irrespective of what calls you want to analyze, you have to use a software, because without software you can't build a spectrogram or waveform of the sounds, because they are created by these sound recording devices. However, these applications will help you to sort of analyze them and visualize them. So now we are going to that part where we're going to visualize sound. So far we have been talking about sound. What is sound? Sound is vibration, and there's crest and trough, which waves, there's wavelength, frequency, etc., etc. There's calls, and within calls you have pulses. Pulses also have some sort of properties. So let us now quickly jump into a call and see what's going to happen. Before that, I'll quickly introduce you this Raven window. You can see this is called menu bar. Please observe my cursor. Okay, on the top file edit, we've played that table window tools help. It's called menu bar. These are the main menus, inside which also you have a lot of tools. And this is called toolbar. This second row is completely called as toolbar. Okay. And this is the side panel. And this is called as Raven desktop. Whatever we are going to work, mostly the work happens on the Raven desktop. As you see, right now, Raven desktop is empty, which means we have not imported any form of sounds into this particular Raven desktop. Okay. Again, I'm repeating menu bar, toolbar, side panel, and Raven desktop. Okay, let's import a sound. So I've already given you guys sounds. If you are on your system, you can also try doing this along with me so that you learn. If you don't have the software, don't break your head. Okay, it's fine. Even if you don't have the software, it is okay for today. But learn today. Write it on notebook or pen. I will also share some manuals and modules where you can also learn, and then you work it out. Okay, don't need to worry. Just first understand what's going to happen. So you see here, file tab. I'll open file tab here. I already have, let's say, you can open any sound files. For example, you can see here sound files, different, it will show different paths which you can open. Okay. So I want to open, for example, here I already have a software, sorry, a file where I've saved the calls, what I shared with you. Okay. So I'm going to open one of the calls. These are calls recorded uh, way back maybe in 2019, 20, like that. Okay. So these are 5 microhylids on which I had worked for some of my around papers, research papers, to compare with one of the species what I described. So now, as you see, Sholigari sound, and yesterday I had told you, like, as you open, you can see here, this sound was recorded at a sampling rate of 44,100 hertz, or 44.1 kilohertz, and 16 bit rate. Okay, sample rate was 44.1 kilohertz, and sample size was 16 bits. And the length of this call is 3 minutes 48 seconds, and has two channels. It is two channel sound, means it is having two different channels. I'll show you what is it also. So let's not waste much of time. If you have Sholigari sound with you, what I shared, please open that in your Raven window. Okay, as you open, you can see different options will come here. No need to change anything. Okay, window, open entire sound, paste window here. Okay, this option you can use when you have very long recording. Listen to me very carefully. When you have recordings of days and months and an year together, if you want to analyze that in let's say in a few days time, then you can open it as paste sound. But however, my sound is very short now. I don't want it to open as a paste sound. Paste sound means you can view, for example, 1 hour recording in one page. Like that, you can have 24 hours recording or 100 hours of recording. But right now, let's not get into that. So, page sound, I'm not clicking, I'm clicking only on open entire sound. Speed, I wanted normal speed. I don't want to, change any of the speed format. Already it's in the same format. I told you 44.1 kilohertz and 16 bit. Okay. Channels, two channel. If you want, you can close one channel. I'll keep it open. I'll change it later in the software itself. Date and time, nothing to change. Calibration, we don't want to calibrate anything. Okay. So everything default. I'm just opening the sound. So as you see two channels here. Two channels means I've kept for my hearing comfort while I was recording, I had recorded this as two channels. Two channels means It will take same waveform and spectrogram from left and right side. Okay, so it becomes two different waveforms and two different spectrograms. As you see here, the if I close this, see here, this is the side panel. I'm going to the second channel and closing it. Okay, so that we don't want two channels. I want only one channel. Right now, I'm coming to the Raven desktop. As you see the Raven desktop, there are two major windows you see. Okay, one is waveform. This is called spectrogram. As I told you, spectrogram is frequency versus time, and waveform is time versus amplitude. Amplitude is this is the amplitude what I'm talking about. So please understand, x-axis for both is time. Okay? You can see x-axis for both is time, whereas y-axis is different. Okay, y-axis here is amplitude, means sound pressure level. You can see 30 kilo units was the highest level recording possible by my device. However, these units represent sound pressure level, means what is the intensity of the sound. What I told you yesterday, if you remember, I told you we have to set the gain levels, right? The gain levels, if you don't set properly, for example, imagine your sound was hitting the zero mark on the recorder. This particular amplitude here, what you're seeing, is under this mark, right? What would have happened? I'll show you here. I'll just click on this waveform now and I'll just zoom in. It would have looked something like that. Okay. This would be 30 value here, and some of the values would have flipped. So your sound was sort of having much sound pressure, then your recorder could document. So as a result, you would see something like this, which is not good. But as of now, you see my recording is not clipped because the highest amplitude sound pressure level which it could record is even beyond this. Means I could have even recorded even till here. But for my safety, I recorded till no, 20 kilo units. Means the sound pressure level was not touching the maximum recording ability of the recorder. Okay, which is the gain setting. Gain setting first you have to set, then only you have to record, which I told you yesterday. So you can see now what has happened because of the proper gain setting yesterday. Okay. Now let's move on to some of the things on. This is the desktop as I told you, and this is called. So you can scroll down and up, holding your mouse. Okay, you can scroll up and down. This is called selection table, which will come to it in a while. Okay, right now let's not break our head on this. Now this is called side panel for participants. This is side panel, and you see there are different titles. You can see axis titles are there. You can also see now if I click on this axis title, it'll tell you now what is. As I told you on the waveform, it is amplitude on the y-axis, and it is time on the x-axis. Here the labeling scheme, and here also frequency on the y-axis and time on the x-axis. You can also have line titles. You can see here, see waveform 1, channel 1, spectrogram 1, channel 1. Not needed, right? We don't want access titles right now. I'll remove that. Position markers, you can see position markers. Where is zero? It will show. See, let it be on. It'll show where is the zero mark. Okay. And the scroll bars, let it be on. And here measurements, if you want data range, major grid, minor grid also not needed. So if you want, you can add any of these components to your waveform or a spectrogram. But once you start analyzing only, all the components become very clear. Right now, some things, even if you click, nothing will come because you have not measured anything. Okay. Later I'll show you how to keep it off. Of course, I told you channel 2, I've kept it off. Okay. And the lines, number of lines. So if you want, you can change this also. See, orientation also you can change. But however, this orientation will not work for us. So let's go with the horizontal orientation. There's also vertical orientation. Let's not do that. Lines. This is very important. This is very interesting. Imagine if you have a very long sound and in one window, like for example, see here, I'll just close the waveform. It's just a spectrogram. So this is a 3 minute recording. Guys, this is a 3 minute recording. And if you see, it's visually not that appealing. For example, I won't know where are my calls because it's very closely packed. So if I break this into more lines, let's say 4 lines, you can see, oh, you can see there are 4 lines now. Now we can easily clearly visualize. If you have a bigger monitor, maybe you can clearly see here. You can even scroll. The sound goes still here almost. Okay. You can even reduce that by clicking here. Okay. You can see in 4 lines the sound is divided. Now I clearly see where are my animals calls. Where is the recordings of the speech. Wherever you have this band, this is the calls. Let me play that, then you'll understand very clearly. Of course, here you can toggle around waveform or spectrogram. See, waveform also, if I remove, click on this, spectrogram will come. If I click on this, waveform will come. If I uncheck, that particular window will go. If I uncheck on both, nothing is there. If you want to work, you have to keep both waveform and spectrogram on. Let me not confuse you. I'll keep it to one only right now. Okay. So this is how it was. So let us begin now. Okay, let us begin to understand what's happening and how to analyze. So I hope you're clear now what is a Raven window and what is Raven desktop, side panel, and menu bar and toolbar. Let's look into a little bit of toolbar options and see what's exactly happening here. Okay, you can also zoom into any of the part of the call by using this button here. See here, I'm clicking here on the toolbar. You have plus minus buttons. So because time axis is same for both, it's going to zoom on this as well as zoom out on this. Okay, so you can also do that here on the side. This here and my cursor you see on the right side, my cursor is here right now at the rightmost back end of Raven desktop. There's a scroll bar. Okay, below the scroll bar you see plus, right? This plus will increase the vertical axis of this, because our active selection is this here, my cursor. This is the screen which is active now. If you want to activate this, you have to click here. See, you can toggle around because at the time only one screen will be active, because y-axis is different for both. Okay, y-axis is different, whereas x-axis you can control here. Okay, whereas y-axis control is here in this sides. Okay, I'm again telling you, uh, x-axis control is here. Of course, y-axis control is here as well, but I'm showing same controls are here as well. See, x-axis control is here also. This is the y-axis control, but y-axis is different for each, because if this is time here, both of the spectrogram and waveform windows have time only. So if you move x-axis, both the windows move at the same time. See, but whereas if you move this y-axis, wherever the selection is active, for example, this spectrogram is active now. Here, blue. So only that particular thing will increase. See now, only spectrogram is increasing in height. Okay. So now you know that whatever sounds you have is only here. See here, this part is the part of the sound where there are spectral information. You see that I've yesterday told you that frequency versus time. But notice this darker band. Darker bands are representing something called spectral density or energies. Wherever there's highest energy in the sound, that is shown as the darkest band. And wherever there's not much of energy, those color scales are shown. If you want to change that, see here, again, I'm telling you this is waveform, this is spectrogram wave. You can go here to this particular part. Okay. If you want to change the color, imagine I'll remove the waveform right now. This is the spectrogram what I have. You can go up here. This is the color scale of the spectrogram view. You can keep it grayscale also. See, grayscale, completely grayscale. If you want to zoom in, we can zoom in. And if you want to change the brightness, see, change the brightness. And contrast also you can change. Now you can see clearly where is your sounds. Okay. So let us keep it like this for a minute. Okay. So you can also play around. There's also cooler colors. See, it will show you everything is highlighted there. Cooler color is what, in the range of blue, cool colors. You can use any shade what you like. Okay. But everything is going to give the same thing. Okay. Contrast. If you want to change the contrast, for example, see, this is our spectral densities are dark, background noise is white. If you want to change it, you can also toggle around. See, your spectral densities become white and background becomes dark. But however, we don't want that, right? We will observe it like this. Now I will sort of reduce the windows and overall size. You can see, I'll play it, then you'll be able to understand what's going on. Okay. I'll open both spectrogram and waveform. So I will play it once. See, the play button is here on the toolbar. Play button is here. Okay, play button. So let me. Are you able to hear?
Yes, sir, we can hear.
Okay, fantastic. whatever was in this, it is playing, right? Whatever was here, it is playing. Okay. Again, I'm going to play just for example. Okay. Now I'll zoom into waveform. Okay. You can see each each particular wave, what you're seeing is a call. As said, I mentioned you, calls can be given as a continuous series or they can be very independent. You can see here most of the time they are independent. There's not much gap. They're continuously producing. Let us take this parameter as a call. Okay, this is the call. Okay, this is the call. Now, this same call, this is the wave. If I zoom into this, see, you can go to the right side and zoom into this. This is how the call looks like. Okay. So this red button here, red, this is zoom to selection. Zoom to selection. Okay. So if you want to unzoom, you can also come back. If you want to zoom in, just click on this red icon. Okay. Yes. So now I've zoomed into this. So you can see this entire waveform, the individual waveform. See, this is the complete sound. Again, I'm showing you. This is the complete sound. Within the sound, you have a lot of waveforms which are having high peaks and they go down, peak goes down. And this type of a thing is called as pulse. If you see, they're distant. Okay, they have a small period of silence here. Okay, very short. So what with this we can record as pulse. So you can see a first pulse, second pulse, third pulse, fourth pulse, fifth pulse, sixth pulse, seventh pulse, eighth pulse, like that. So a call has pulses within it. Okay, so please understand. In frogs, it's quite simple. A call, so zoom into the call, pulse, but not all the time. Sometimes these pulses won't be clear. Like, it'll be completely looking like as if it's single. If you read my paper, like a paper which I sent you yesterday by a caller and Vences, you'll be able to see different. So sometimes calls are pulsatile. Pulsatile means you can't see the pulse, but this is the pulse record. Means you can clearly see the pulse. Okay? You can clearly see the pulses. So what happens is if it is a pulse call, you can even work on the pulse characteristics. So let us start analyzing some of the properties now. So let me just have both the windows. So you can see here now I have, I'll just get back to this. Probably this call is beginning here. Okay. So let me just select that. Okay. If I just select this and move to next sound, you can see that my earlier selection goes off. Okay. I selected it, but you can see here some values in the selection table. It is showing what is the lowest frequency, highest frequency. That's all. Lowest frequency means zero. Highest frequency is, if I zoom into the CC here, if I zoom it out, you can see highest frequency this has recorded here is 22 kilohertz. After that, it is black. Okay, so I'll zoom it a little bit. You can see the highest frequency what my device has recorded is 22.05 kilohertz. That is because the sampling rate, what I said, was 44.1 kilohertz. I told you already, your sampling rate should be double the frequency of your animal because I know my frequency of the animal is less than, let's say, 10 kilohertz. But minimum I should have had is 20 kilohertz. But I know for sure I'll get all the details if I record in 44 kilohertz. So I've recorded in 44 kilohertz. But the device capacity is to take half of its frequency values in preparing spectrogram values. Okay. It has taken only 22.1 plus 22.05. 44.1 will be the actual sampling rate. So this frequency is also referred to as Nyquist frequency in scientific studies. So Nyquist frequency is the highest frequency that your device can record actually, which is half the sampling rate. So if you set it, let's say about 90 kilohertz, it will be 45 kilohertz. If you set it to, let's say about 22, it will be 11. Please understand that. And now let's come to the spectrogram. In the spectrogram, wherever you see darkest band, see darkest band, this particular part of the sound is the feature called as dominant frequency or the peak frequency of this animal. It is like a signature. Now you have your signature very unique. For every single species, this dominant frequency is very, very unique property. Okay. And this is called a spectral property. Please understand the spectral property, what we can take from this call is dominant frequency. However, when I select only this much here, the entire wave is getting selected because you know that in the wave there is no spectrogram. It is just waves. It is taking only the x-axis. Whereas here I can have a different y-axis here because I can see I can change. But here I can't do that because there's nothing called as different frequencies on the y-axis. It's just kilo units. Okay. So here if I select, it will also select the entire spectrogram. But if I here make any selections here, it will select the entire waveform because the waveform doesn't have any spectral densities, whereas here frequencies vary. Okay, I can choose very unique frequencies, but here it will choose the entire window. So for studying any time limited properties called temporal properties, please use waveform. Again, I'm telling for studying any time limited properties means temporal properties, use waveform. For studying any sort of spectral properties, you have to use the spectrogram. So let us start the analysis. If you have any doubts so far, please ask me now. So far, if you have any doubts, please ask me. We are moving into the analysis part. Feel free. So this is the waveform. Again, I'm telling you, wave. This is how the sound actually looks like. This is what the software has built by taking something called fast Fourier transform, which is a physics phenomenon. Okay. Deepak, can you unmute and tell me what exactly you want?
I mean, that last part you explained, right?
Huh.
Last. Yeah, that can you
Okay.
explain once again? Yeah.
Yeah, what I was saying was, Deepak's here, like, if I select on spectrogram, see spectrogram's y-axis has spectral densities, means different parts shows different densities, like, different gradations or energy levels. Okay, this darkest band is highest energy. So even if I select this much here, because time is linked between both x-axis of this waveform as well as spectrogram. Even if I'm selecting any part of this, complete waveform gets selected because in the waveform you don't have any such y-axis difference in the values. It's just kilo units. You can't select it separately, okay? Because kilo units we cannot be using as a separate because it's a complete wave, right? You can't use different choose different parts of the wave. You have to always choose the complete part. So the software is designed in such a way that you can choose uh, any part of the spectrogram, but you can't choose some part of the waveform. Okay, that's what I was saying. If you choose any part here, it'll select the entire waveform in that particular length. Okay, is it clear, Deepak?
Yeah. Fine.
Okay, now let's move on to the analysis. Now I will use see one of the calls here. Let's say let's open it and observe it just to say where it is starting and where it is ending.
Sir,
You can also use this thing.
sir, sorry to interrupt. Again, in 10 minutes, we have to rejoin.
Yeah, yeah.
Yeah.
Yeah, no problem. Participants, please note that after about 10 minutes, we have to rejoin. So that's not a problem. We can rejoin. So let's say here, let us only use the waveform now. See, use only waveform to make any selection because waveform selections are always better because anyways, it will clearly show you the time boundary here. I can see, I'll zoom in a little bit more. I can see the first wave has started here, almost here. And the last wave has almost ended here. If you want, you can even zoom it and see. Okay, zoom it and see. Just see. The first wave started here, means the first pulse, and the last pulse ending. This is called as call duration. Okay. Now, how do I commit this? Because if I move my cursor, it goes off, right? So if you want to commit it, do this selection using your mouse. Okay, and then this is an uncommitted selection. You have to commit it by pressing enter. Now this becomes a cyan color. See, this is called fifth selection now. Henceforth, this selection will remain whatever you do unless you have not saved it. So if you have saved it, this selection is going to remain forever. Okay. Now you see here. Now this has become, can you see here in the selection window, it has become cyan color, which means we have already selected this. Now I'll select one more uh, sound. Okay. From here to here. If you want, you can zoom in and see if it's proper. Just check that whether you have selected it properly.
Vineeth, sorry, what was the
Commit that
option to
sound.
select that? What is the
Sorry?
option to commit that sound?
Just press enter.
Okay.
Just press, like, make the selections here, make the selection and press the enter button. It will become cyan color. Okay, let us make few more selections. Okay, if it is the bird sounds, there will be different syllables you can select. See, I'm not saying it very precisely. I'm just teaching you so that if you want to be serious, you have to see properly and zoom it and see. But I'm doing it almost close to precision, but it's fine. Okay. So I'm making few more selections. You can also change it later if you want. Okay. Let's say I made 5 selections here. So I've made 5 selections, proper selections, active selections. You can see in your selection table 1, 2, 3, 4, 5. Now my spectrogram window, I've kept it off. But even in the spectrogram window, it is on only because it's selected only because I told you time on the x-axis is linked for both spectrogram as well as waveform. Okay. But if you had made only selection here, you would have selected only a part of this. But however, it would have selected the entire wave. Doesn't matter. So now whatever is coming as red is uncommitted selection. I can make it and leave it. If you want transitively to see something, you can also use that. But otherwise, commit your selection. Very important. If you want to do any sort of analysis, you have to commit your selection. Now you see on the selection table, if I remove this, only 5 values are coming. If I add this spectrogram, there are 2 values coming for each number. That means, for example, first selection, there is the spectrogram. Here, this symbol is spectrogram. This is, sorry, this symbol is waveform. This is spectrogram. Second, active selection, there's a waveform, spectrogram. Third selection, there is a waveform, spectrogram. So it is showing that property, okay? So it's simple. So we have actively made selection. Now we have to add some measurements to it because this is incomplete because no data, I have nothing, no data available here because I want to know what is the frequency of the animal, what is the duration of the call. I want to even maybe count pulses. Pulses have to be manually counted. You can't do it in the software. Of course, you can develop a Python software to calculate that, but right now we are doing it manually. Okay. So what you do is see right click on the selection table anywhere. Okay, on the selection, you can click it here. Okay, anywhere on the selection table header. This is the header. Okay, right click, you get this table. In that, you go to choose measurement. I'm repeating again. Once you have done active selection, click on the selection table header and go to choose measurements. And here you have close to 50 different values given here. Measurement values. These are called measurements. You can add any measurement to any of the calls which you have actively selected. For example, I want to know what is the duration of the call, and duration of the call is called as delta time. Here, I'll click on that. So you have to click. I can also unclick that. If I click on delta time, it will go here. Okay, it will go here. Now I want even the dominant frequency. Dominant frequency. It is called as maximum frequency or peak frequency. Let us use peak frequency. If you double click it, will go there. If you single click, see, you can also remove that. Now bring it back. If you click on that and press this leftward arrow, it will come to the selection. Okay. You can also check what is the energy if you want. Okay. Energy levels. Let's say energy. Okay. Energy of the sound. Okay. In decibels. Vivek, can you just on your mic?
Hello, sir.
Yeah. What is the problem you're facing?
I did the active selection, but in the selection table is empty. It is shown empty.
Uh, do you see the selection table or not? Do you see
No,
this like as you
no,
this table comes at least?
no, the table did not come.
You have to lift this here. This particular will be like this. You have to lift this bar. Then you'll be able to see. It's hidden there. That's
Okay, okay.
if you lift this, you'll find. Are you finding?
Mm, no, maybe I will try later.
Yeah. Otherwise, okay, you should be able to get it because it's hidden somewhere. Like, go to the bottommost part of the Raven desktop. You'll find this double bar. Just lift that up. You'll see it hidden
Okay,
here.
okay.
Okay. Yeah. So now, guys, now we have selected whatever, let's say three, four properties, what I want. Okay. Let's not worry on that. So, uh, we have selected few properties. For example, delta time, peak frequency, energy. If you want, you can, and otherwise you can delete. Now, delta time. See, the delta time means duration of the call. You can see, I'll use only the waveform window. If you see here, the duration of the first selection means the call which we have selected is 0.7647, means zero point 0.7 seconds. Okay, 0.767. Second call is 0.77 seconds. Third call, 0.76. Fourth call is a little longer. See, fourth call is interesting. It's a little long. Maybe my selection is wrong, but it's fine. Okay, because I have to select it. I can also sort of change it by pressing on that. I can even modify it slightly. Okay, now this may be proper. Okay. Yeah. So now it is changed. You can see slightly the values are changed. Now fifth one is 0.79. You can see there's a range of values here. Range of values in this file. If you want later, you can also open this in a Excel file and plot or take the average. You will find out that okay, this species, this microhyla sholigari or sholiga narrow frog, calls with calls being about 0.8 seconds, means 800 milliseconds long. This is one of the property of the call. So if the call is around 800 milliseconds, the sholigari species may be closer to that. Means in terms of one of the properties, it's not the only property because call duration remains constant within a species. Very, very important. Okay. Now we will move on to some more properties, spectral properties. Why peak frequency is not shown here? Can anybody tell me? Why the peak frequency is blank, energy is blank? Can anybody answer this question? Why am I not able to see anything here? It was coming at that time, but now this is blank. Okay, not a problem. The reason is because I've kept the spectrogram off here because frequency value is not on the waveform. Frequency value is on the spectrogram. Energy value is not here. Energy value is on the spectrogram. Here it comes. So if you keep spectrogram, see, all the values are coming. See here, it's coming here, peak frequency as well as. So what is the frequency of this sound? Almost constant, right? Frequency is almost constant. You can see it. If you want, you can even add maybe maximum frequency. Let's see if there's any difference. Sometimes frequency will slightly matter on both the amplitudes. Okay. Okay, I think there's not much variation. This frog is continuously calling at the same, almost same frequency, at least in this calls. Okay. If you want, I will even move further and show you into next part of the calls. Let's see if there's any variation in the frequency. It's also the same. Okay. Almost same. Let's come to some other part of the call. Okay. There's not much difference in the values, right? Peak frequency value is almost constant in this. Sometimes it does vary. Then you have to take average of the values. Okay. It is like a signal